Okay, final example 4. Find 4 consecutive integers. Kaylin, 4 consecutive integers look like what?
N plus 1, N plus 2, and N plus 3.
Perfect. Okay, consecutive integers have a +1 pattern. So n's the first one, add 1, then 2, then 3 to get the next 3. So we have 4 this time. Let's say find 4, so we list 4. All right, once again we have the word such that, so we're ready to go. 5 times the sum again. So 5 times the sum is 5 parentheses. The sum of the first and the fourth. First and fourth. So we're adding the first to the fourth. That's n added to n plus 3. The word is equals. Once again, it has a greater than statement, so we ignore the greater than. It says 8 times the third. The third is n plus 2. Once again, the third's represented by multiple pieces. To do 8 times n plus 2, I have to put parentheses around that to make sure 8 multiplies by both pieces of it.
Never use the second one.
Haven't used the second one yet, have we? We will sometimes. You don't have to use all of them. All right, so they'll make some statement of fact about the list, but they don't have to use all the numbers in the list. And then finally, 1 greater than happens after the word is, so +1 goes on the right-hand side of the equation. So we create this nice equation. It's pretty much the same structure as the last equation, right? I can add these together. I can't do anything here, so I distributed property of that. So I'd probably go about the same. Well, let's do this one the other way. I'm going to distribute this first, and this. Just distribute everything all together once in the first step. So there's 3 things here, so 5 times all 3 things, we get 5n plus 5n plus 15 equals 8n plus 16 plus 1. All right? If I combine like terms on both sides, 5n plus 5n is 10n, 15 doesn't have a like term, 8n doesn't have a like term, 16 plus 1 is 17. And what's left is 8n moves to the left, 15 to the right. Opposite sides, both signs change when you move. So you get 2n left on the left-hand side. 17 minus 15 is 2. At the last step, then divide by 2. 2 divided by 2 is 1. 1 is an integer. That's what we're looking for, integers. We're supposed to find 4, so the next one up is 2, then 3, then 4.
Right. You don't say n equals, right?
No, just list the integers for me. I'm going to show you one extra thing before I turn the video off here in case this should happen in homework, which it probably will. Suppose you do all that work, you got your n, let's say n plus 1, n plus 2. Let's say we did all that and we got all our work here. We end up with n equals negative 17. Okay? We're supposed to list our 3 integers based on the first integer being a negative number. It hasn't happened yet in the homework, in the examples. If I apply this pattern to get the next 2 numbers, negative 17 plus 1 is negative 16, not negative 18. Be careful that you're adding 1 to a negative number, which subtracts the numbers. Negative 17 plus 2 is negative 15. Make sure that you're adding, you're adding algebraically, which negative plus positive actually creates subtraction to get the list of numbers. A lot of times I see people go the wrong direction. They'll do everything right, get this answer, get this, and then they'll go the wrong direction, get the wrong list, and end up getting the wrong answer. So I don't want that happening to you because you're in a hurry to get done with your homework. I'm sure everybody knows negative 17 plus 1 is negative 16, but a lot of times we don't think it through. We just jot stuff down on our paper without thinking. So make sure you're thinking through, and again, don't forget anything. Remember everything I ever teach you, and I'm expecting you to do that because I'm not going to be reteaching stuff in higher level classes that you should already know how to do when you get to those classes.